So we heard about the recent days, this Cape Town, recent days about the scarcity of water comes in this dryland area. Okay, so this is how this beautiful Africa continent looks like. Let us move towards our own country. See how is our biodiversity, our own country. Look at our country, like Rajasthan area, we have some yellow color there. We have a small land there, stretch of land. We have a Thar desert in Rajasthan area, and we have Western Ghats. Of course, we have a greenery. We have a thick forest. Center of Africa as well, we have forest. And you can look at these monsoon clouds over the mother. You can easily make it right. This is the desert area and the coastal area and center of India. You can look at it. This is the desert area, coastal and center of the monsoon clouds. Okay. Even if you look at any part of the world and how is the world, you can look at Australia. Australia, more than 66% land is dry land in Australia. Okay, and here you can see some greenery there. This side we have something forest. Okay, apart from that, you can some little coastal area we have little greenery. Remaining is the dry land in Australia. Okay, so this is how you can look at any part of the world. Looking at the color, we are able to see how is the biodiversity of different part of the world as well. So now our Mother Earth is covered with a blanket of air. We call it as atmosphere. It contains different gases. We have nitrogen gas about 78%. We have 21% oxygen gas, without which we can't live. And we have other traces of gases like carbon dioxide, carbon monoxide, methane, and bases about 1%. Okay. And all these gases are held by the gravitational force of Earth. We call it as atmosphere. If there is no gravitational force, all these gases would have been escaped from our Mother Earth. Okay. So now, today's topic is on our atmosphere. Let us take a small journey into atmosphere. See what's happening in our atmosphere. To study our atmosphere, nowadays we are using the help of the satellite. Mainly, we are using two types of satellite to get the information or data. Okay. So you can see there are two types of satellite going around our Mother Earth here. Okay. And at the center, you can see some satellite, even though they are moving, it looks like a stationary for us. Okay? So these satellites which are at the center here, so these are all known as geostationary satellites. So these satellites are kept around some 36,000 feet above the equator. Okay? So these satellites in India we call this an INSAT or Indian National Satellites. In USA they call this as geostationary operational environmental satellite. Okay? In short, they call this as a GOES, GOES. Okay. These are why if you keep the satellite at 36,000 km above the equator, then the rotational speed of the Earth and the rotational speed of the satellite is same. Both are moving the same speed. That's why if you observe from the Mother Earth, it looks like a stationary or fixed at a particular point. And suppose inside of India, this is always above India, and we can take the light rate of the whole India. This is about the one satellite. That is the geostationary satellite at 36,000 km. And we have one more type of satellite. It is moving pole to pole here: red color, yellow color, blue color, white color. You can able to see this. Yes, this moving pole to pole. This is known as the polar satellites. Okay, and these satellites are not at 36,000 long distance. It is very less distance, about 900 to 1,200 kilometers. Okay, it moves pole to pole. As Earth moves like this satellite will move pole to pole, so that the instrument in the satellite will cover every inch of the Earth's surface as well as the atmosphere. And this satellite which is moving pole to pole here in India, we call this as the Indian Remote Sensing Satellite or IRS sensor satellite. In USA they call this as a Polar Operational Environmental Satellite. In short, they call this as a POES, POES, POES. Geostationary GOES, GOES, POES in USA. So these are two types of satellite which gather the information. Now I have a data with me, one of the geostationary satellite of USA that has taken the data of the cloud formation for the last 1 month. Last 1 month, we have seen how is the clouds and where they are rain. Yesterday also, today also we have a rain. So let us see how these clouds are moving from the last 1 month. Okay. So these are real-time data. I will try to show you today morning data also. Okay. I will just focus this cloud over the Mother Earth. You can see this is the three type colour clouds here. In the real sky, you cannot see these three colors. Okay, And because this color, what you are seeing, this is an infrared imagery. Okay. So here the color depends on the temperature of the cloud. Since these clouds over the mother earth have been categorized into three categories depending on the height. The cloud very near to the earth's surface here represented by the white color cloud. Okay. Above the white color, we have one more layer of cloud, that is the purple color. Above the purple color, the tallest cloud of the mother earth is the blue color. You can see the center of the purple, you see the blue color. And there are three layers, okay, and they are at different heights. What these clouds will do, the clouds which is very tallest, that's a blue color cloud, is very cool compared to the purple color cloud below that. The purple color cloud is cooler than the white color cloud below that. And all these clouds are cooler than the surface of the earth, which is hotter compared to these clouds. What these clouds will do, it will absorb energy or heat from the earth's surface, and these clouds will start giving out some energy called radiation. Okay, these clouds gives the radiation at different temperature because the clouds are at different height. Okay, so the satellite instrument job is very simple. It will identify the temperature at different spot there. Okay. So now, depending on that, we can create this infrared images. Okay, I will just focus these clouds over there last month. So this is 5th March. Okay, 5th March at 8 a.m. in the morning. This is the cloud formation. Now I will just focus on Asian region. Yeah, now we can see this is Asian region. All the side you see India and its surrounding. You can see the tip of the last, there are little clouds at the tip of India there, and of course some clouds beyond this Arabian Sea there. Okay, I will just move these clouds, okay, slowly one by one day after another day. You can see there are a lot of cloud movement in the beginning of the March, and sometimes we have some clouds and we have some showers in March also. Some places of Karnataka as well. We have received some rain due to these clouds, and this is cloud in March. You can see a lot of cloud formation at the Indian Ocean there, and we have received some rain in South India as well, North Karnataka in other places. And you can see this is the last few days cloud formation. Yeah. Now this is the last yesterday and today last few days. Yeah, now let us see the what is that date. This is 4th today, right? 4th April at 7:40 the today morning. Today morning at 7:40. This was the condition. You can see another 2 days or 1 day we have some clouds. Afterwards, you needed to worry about this. We have a hot sun again. Okay, you can see clouds are little away. Of course, beyond you can see some clouds are there still. Okay. And the second week of April, we may get some more rain. But at present, next week, we may not get much rain. Can you make out here? Yeah. And here you can see this. This is the today at 7:40. After 7:40, still data is downloading the further data. It's a big file. It's downloading that. Okay. So that's how a real-time data can be studied using the science on a sphere. That's the specialty of this science on a sphere. Let us take up some of the natural disaster which happens some part of the world, then the satellite will track that. I have a data here, a volcanic eruption in a small country called Iceland. Iceland is a small country. There is a mountain full of ice. There was an eruption of volcano. It started pushing poisons and dust particles to a greater height of some 36,000 feet above the surface. You can see this. The country where smoke coming, that is Iceland. Okay, the smoke is the dust particle and poisonous gas that is leaking out of the volcano there. Okay, and whenever the volcano erupts, there will be a red hot liquid, lava. It's a molten liquid, the hot temperature liquid coming out of the interior of the Mother Earth, and it is coming in contact with the ice there because icy mountain. Ice start melting and water start flowing down the valleys mountain. Okay, so you can see this direction of this pollution will be different direction depending on the wind direction there. Okay, so it start spreading all other directions as well. So this is how a natural disaster which creating the pollution can be studied using the science on a sphere. So now this is the pollution created by the natural disaster. How about the human activity? Due to our activity, human activity, we are creating a lot of pollution, more than 100 types of material we are pushing into the atmosphere due to our activity. Okay. So let us see. I'm not taking all big list of 100 or more. I will take one small example how we are polluting our atmosphere. I'm talking about this here, this black carbon aerosol or sulfate aerosol. Okay, this black carbon, you heard about the carbon dioxide. Okay, this black carbon is nothing. It is different from your carbon dioxide. What do you mean by black carbon? Black carbon is nothing but when you burn the firewood, the thick black film which is coming out, we call it as a black carbon, where the particle size of the black carbon maximum thickness is about 0.2 micrometer thickness. What is the reason for this? This black carbon reason is when you burn, it is due to the incomplete combustion. That means if a substance not given a proper temperature, forcibly if you start burning the substance, then it converts it into black carbon. Okay, if you give a proper temperature, burn it, it converts to carbon dioxide. If you don't give a proper temperature, forcibly if you burn, it converts to black carbon. It dries up, it is suspended in the atmosphere as a layer, we call it aerosol layer. Okay. So what is the reason for this black carbon? It is due to this burning of this biomass in open air that converts to black carbon. Okay. Suppose over Bangalore, there is a black carbon aerosol layer is there. What happens? Sun, we are getting sun rays or heat rays. That will be trapped in this layer. We feel very hot here. Okay. And you can see this pencil graph there down there given there. Tip of this stick there. You can see white color down there written 0.2. That means if you see some white patches there, there will be a black carbon aerosol layer where the particle size maximum thickness is 0.2 micrometer thickness. Okay, and you have one more pollutant similar to the black carbon, that is sulfate aerosol due to sulfur trioxide dioxide atmosphere. Okay, so you can see this. If you see yellow color, it is similar to the black carbon, but it is due to sulfur dioxide trioxide. And if you see yellow color patches, that means sulfate aerosol particle maximum thickness about 1 micrometer thickness. What will happen if there is a sulfate aerosol in your atmosphere? Suppose the Bangalore there is a sulfate aerosol layers of that. Sun, we are getting sun rays or heat rays that is reflecting the layer and going back. We are not getting heat properly. Cooling will increase. Both will be dangerous. Okay, let us see which part of the world contributing more black carbon and sulfate aerosol. Okay. So now I just come to our own Asian region. You can see here this is India, China, Bangladesh, Taiwan, Myanmar. You can see here all these countries are there. Now carefully observe. You can see some white patches coming there. That means the black carbon is maximum in Asia. Okay, Asians we are creating a lot of black carbon by burning this biomass in open. What about the sulfate aerosol? Yellow color. Yellow color you can see all over the world. You can see over Asia. Even if you look at Europe also you can see. Even if you go to USA, look at here. USA the yellow color is quite common, but white patches you can see only in Asian regions. Okay, so that's how a pollution. I give one small example. This is about the black carbon like carbon dioxide, carbon monoxide, methane, other traceable gases will be stated within this size and this layer. Okay. Now I will take up one more natural disaster, earthquake. Suppose earthquake hits some part of the world is a very panic and disastrous natural disaster. You remember that earthquake which has taken a lot of Indonesia, Nepal and Japan. In 2011, there was an earthquake in coastal Japan resulted in tsunami. The tsunami damaged the Fukushima nuclear power plant which is in the coastal area of the Japan. When this news comes in the news channels, so we are in India, we are very much worried about this nuclear accident due to this earthquake, and I will just show you that. You can see the Japan there. You can see this red color what you are seeing there coming out of that is the nuclear radiation leaking out of the nuclear power plant. And nearly some 25 to 30 days, a nuclear emergency was declared in Japan. Every day, nearly some 300 to 400 tons of nuclear waste have been added to ocean. A lot of creatures died in the ocean. Our news channels used to show this, these disasters due to that earthquake. And in fact, they have calculated by the scientists of Japan what is the total radiation that has entered into the atmosphere during this period. It is 30 to 40 times more than Hiroshima and Nagasaki nuclear bomb blast in 1945. Okay, that much radiation entered into the atmosphere. And in fact, in USA they have calculated after the 24 hours after the incident, they checked the radiation in their every country checked their atmosphere. In USA they found it is 1,000 times less than what they see near Japan. Look here, the red color what you see is more radioactive. It's very near to the Japan. Okay, the particle which moves in the anti-clockwise direction, there was a low pressure, heavy rain. The particle which moves in the high pressure area, it starts spreading all over the world. Okay, so this is how a nuclear disaster, which is creating the nuclear happened due to the tsunami. The reason for the tsunami is that way. Okay, so this is one type of the pollution. I come to the last interesting point before concluding. All of you know it's very difficult to move our vehicle on the road traffic nowadays, whichever the city for that matter, the road traffic may be increased nowadays. Suppose you are traveling in an aeroplane, how will be the air traffic? Whether the air traffic will be free. Wherever you want, your aeroplane can move in the airspace there. Look here each fish-like thing moving is one on aeroplane. Just to USA, I am talking about just to USA, there will be only 87,000 flights in 24. Within 24 hours, just to USA, there will be airspace, there will be only 87,000 flights just to USA airspace. You can imagine all over the world how many flights will be there in 24 hours, how much each one will contributing pollution in the atmosphere. One interesting thing, this number of flights will suddenly decrease in the midnight, 24 hours, 12 o'clock, midnight to around some 6 o'clock, 7 o'clock in the early morning, because most of our domestic flights won't fly in the midnight. Most of the domestic flights will be grounded in the midnight. Okay, now you can look at Europe. Can you look at Europe air traffic? Around 12 noon. Let us say USA in the early morning, around 8 o'clock in the early morning. You can see this is the air traffic for USA. What about India at midnight, 12 o'clock, when you are in a deep sleep, midnight? How many flights will be over India? That also I will just show you. So this is around 11 o'clock for India. Still there are some flights. Even 24 midnight also you can see there are a lot of flights. Few light flights of course, not much. There are international flights at very high altitude. You cannot hear the sound also. Okay? And now you can see the Asian region, all these airport will be active early morning. Around all this takeoff will be all the domestic flight will go into air, and you can see this becomes, even if you look at Europe at the midnight, only few flights are there in Europe then. Okay? Now Europe, the eastern side there is a sunrise. You can see in Europe there will be a sudden increase in the morning hours, early morning around 8 o'clock. Just carefully observe this Europe area there. There will be a sudden increase in the number of flights in the early morning. Okay. Because all these domestic flights will just move into the air. You can see there is a sudden increase around 8 o'clock in the morning. Okay. So these visuals what I show is known as a data set. So these data sets are developed by the NOAA, NASA, and there are so many universities also working for this. And every week or monthly once they are adding the new, updating the data set, new data sets will be added to the website. So using data sets, I just taken some 10 data sets, I made a show on atmosphere. I can take another 10 more data sets. Same subject or different subject, we can have the shows on different subject. We can study even a subject on solar system, sun, moon, Jupiter, Saturn can be created here, and we can show even a wonderland, a biodiversity, different part of the world can be shown, and we have a show on ocean in the treasure. The treasure of the 5 ocean with that data can be animated and shown here. So this will be a very good tool for students, teachers, scientists, research scholars, even for a common person who want to know more about science. This science on is very good. Even a science fictional movie can be played on this. Okay. In fact, these facilities of science on sphere we have introduced at our Vishweshwara Museum when we celebrated our golden jubilee of this museum in 2015. Okay. That time this was the only one in whole Asia. Now all over India we have more than 26 science museums and centers. Some places already we have installed this facility. Okay. I hope all of you enjoy this show. Thank you all for watching. Thank you.